Hand a professional software engineer a complex real-world bug in a massive GitHub repository. On average, even the best AI models have struggled to resolve more than a fraction of these issues autonomously. But that just changed. The SWE-bench-Verified test is the gold standard for AI coding, and a new contender just posted a record-breaking score of 77.8. To put that in perspective, we're moving from AI assistants to AI engineers that can actually fix the codebase. This isn't just a minor iteration. This is GLM-5, a massive open-source model that is currently outperforming some of the most famous closed-source giants in the world, and the architecture behind it is genuinely brilliant. GLM-5 comes from the labs at SWE-AI, and it's a total beast of a model. We're talking about a 744 billion parameter architecture that's pushing the absolute limits of what open-source AI can achieve. For a long time, the biggest and best models were locked behind API walls. You couldn't see how they worked, and you certainly couldn't run them yourself. GLM-5 is changing that narrative by bringing frontier-level power to the open community. But it's not just about size. It's about how that size is managed. Because running a 744 billion parameter model the traditional way would be a hardware nightmare. That's where the mixture of expert strategy comes in. To understand why GLM-5 is so efficient, you have to look at its active parameters. While the total weight is 744 billion, it only uses 40 billion parameters for any given token. It's like having a massive library, but only pulling the 3 books you actually need. This mixture of experts, or MOE, system allows the model to maintain the reasoning depth of a giant while keeping the compute cost manageable. It's the secret sauce that allows it to punch way above its weight class. And when you apply that efficiency to software engineering, things get wild. We aren't just talking about writing a hello world script anymore. We're talking about agentic engineering. The 77.8 score on SWE-bench-Verified is a massive deal because this benchmark uses real GitHub issues from popular open source projects. These aren't toy problems. They're the kind of bugs that keep human developers up at night. To pass these tests, the model has to browse the file system, understand how different modules interact, and write code that doesn't just look right, but actually passes the existing test suite. It's a grueling test of logic and context. And GLM-5 isn't just barely passing, it's setting a new standard. It's demonstrating a level of autonomy that suggests we're entering a new era of software development. But how does the architecture actually pull this off?
Before we dive into the technical guts, we need to appreciate the scale of the challenge. Training a model this large requires a staggering amount of compute and a very clever data strategy. SWE-AI had to balance the massive 744 billion parameter count with the need for the model to be useful in the real world. If it's too slow to run, it doesn't matter how smart it is. This tension is what makes the GLM-5 architecture so fascinating. Now let's peel back the layers and look at the mixture of expert system that makes this 40 billion active parameter engine purr. It's a masterclass in AI engineering.
Imagine you're building a house. You wouldn't hire 100 general laborers to do everything. You'd hire a plumber, an electrician, and a carpenter. That is exactly how Mixture of Experts works. In GLM-5, the 744 billion parameters are partitioned into specialized experts. When a request comes in, a router network decides which experts are best suited for the task. It only activates the top performers, saving massive amounts of energy. This means that for every word the AI generates, it's only using about 40 billion parameters. It gets the intelligence of a massive model with the speed and efficiency of a much smaller one. It's the ultimate architectural cheat code. But don't let the 40 billion number fool you. Because the model has 744 billion parameters in total, it has a knowledge capacity that is vastly superior to smaller, dense models. It has seen more, learned more, and can store more nuance. Think of it like a brain that has specialized regions for different languages or skills. When you speak English, your French neurons stay quiet. GLM-5 does this at a scale that was previously only seen in the most expensive closed-source models. And the routing isn't just static, it's learned during training. The model literally figures out which parts of itself are best at solving specific types of coding bugs or architectural problems. One of the biggest technical hurdles for MOE models is expert collapse, where the router keeps picking the same few experts, leaving the rest of the 744 billion parameters to waste away. GLM-5 uses advanced load balancing to ensure every expert stays sharp. By forcing the model to distribute its learning across all 744 billion parameters, ZPU AI ensured that GLM-5 has an incredible breadth of knowledge. It can handle obscure programming languages and niche frameworks just as easily as Python or JavaScript. This architectural depth is exactly why it can handle the SWE-bench-Verified challenge. It doesn't just guess, it uses the right expert for the right part of the codebase.
Now, let's talk about the hardware elephant in the room. Even with the MoE efficiency, a 744B parameter model is massive. It requires a significant amount of VRAM just to load the weights into memory. For the open source community, this is a challenge. You can't just run this on a single consumer GPU. You need a cluster of H100s or a very clever quantization strategy to make it fit on more accessible hardware. But here is where the community gets clever. Techniques like 4-bit quantization can shrink the model's footprint significantly, potentially bringing this 744B giant down to a size that high-end workstation users can actually experiment with. Despite the hardware requirements, having a model of this scale in the open is a game changer. It allows researchers to study how these massive MoE systems actually make decisions, which is often a black box in closed models. We're seeing a shift where the open models aren't just catching up, they're starting to lead in specialized domains like coding and agentic workflows. And that brings us to the most exciting part, agentic engineering. Because GLM-5 isn't just a model you talk to, it's a model that can act. It can manage the entire software development lifecycle autonomously. Let's look at how that actually works. Most AI today is reactive. You ask a question, it gives an answer. But agentic engineering is proactive. You give it a goal, like fix this bug, and it creates its own plan, executes it, and verifies the result. GLM-5 is designed with this loop in mind. It has the reasoning depth to realize when its first attempt at a fix didn't work, and the persistence to try a different architectural approach until the tests pass. This is the agentic shift. We're moving from AI as an autocomplete tool to AI as a full-fledged team member that can manage the entire software development lifecycle, or SDLC. To achieve this, GLM-5 was trained on a massive corpus of not just code, but coding actions. It understands how developers use terminal commands, how they navigate large repos, and how they interpret error logs. It's the difference between reading a book about swimming and actually getting in the pool. GLM-5 has virtual experience in the developer's environment, making its suggestions much more practical and less theoretical. This is why it dominates the SWE-bench. It knows that a fix in one file might break a dependency in another, and it proactively checks for those ripple effects before declaring the job done. Of course, this level of power brings up the question of reliability. Can we trust an autonomous agent with a production codebase? This is the central debate in the engineering community right now. Skeptics point out that while 77.8 is a record, it's not 100. There is still a long tail of complex multi-step reasoning where AI can get lost. Human oversight isn't going away. It's just moving to a higher level of abstraction. Instead of writing every line of code, the human engineer becomes the architect or the reviewer, guiding the GLM-5 agent through the most complex parts of the system design. The implications for the industry are massive. If an open source model can handle 77% of verified software issues, the speed of innovation is about to accelerate exponentially. Startups will be able to build complex products with much smaller teams. And because GLM-5 is open source, this power isn't just for the tech giants. A developer in a garage can now have the equivalent of a senior engineering team at their fingertips, running on their own local or cloud infrastructure. This is the true promise of open source AI. It levels the playing field. It takes the most advanced engineering capabilities in history and makes them a public good. GLM-5 is more than just a model with 744 billion parameters. It's a proof of concept for a future where AI and humans collaborate at a level we've only seen in science fiction. The technical architecture, the mixture of experts, the 40B active parameter efficiency, and the agentic training all point toward a world where software doesn't just run, it evolves. We are standing at the beginning of the agentic era, and if GLM-5 is what we can achieve today, the next few years are going to be absolutely wild. The question is, what are you going to build with it?